Before we can begin to understand the identification of hazardous materials, we first need to look at the toxicology of potentially harmful chemicals and hazardous materials. The basic purpose of identifying hazardous materials is to educate the person who comes in contact with the material, so as to provide proper information and protection for that person's health and safety. To begin this process, we need to understand some terms and definitions. First, toxin is any of a group of poisonous, usually unstable compounds generated by microorganisms, plants, or animals. Certain toxins are produced by specific pathogenic microorganisms and are the causative agents in various diseases, such as diphtheria, tetanus, and others. Toxicity is the effect of specific quantity or dosage of a specific toxin or chemical. Toxicity enters the body through ingestion, absorption, or inhalation. Ingesting means swallowing of a substance through the mouth and into the stomach, generally followed by its entrance into the small intestine. Absorption means entering the body through the skin. Substances that absorb through the skin sometimes get into the bloodstream. Breathing causes us to inhale substances, which in return travels en route to the lungs. Our lungs are so rich in blood vessels that any substance inhaled into the lungs are readily absorbed into the bloodstream. Toxic effects upon the body can be defined by the words acute, chronic, latent, or irritant. Acute is generally regarded as a severe injury caused by a one-time, relatively short exposure to a chemical substance harmful to the human body. Chronic toxic effect is an injury or disease that manifests itself after a relatively long period of time has elapsed since the initial exposure to the substance causing some type of ailment. Latent effect is an injury or disease that remains underdeveloped until an incubation period has elapsed. The period of time could be hours, days, months, or years. Irritant effect is a chemical substance that injures the tissues of the respiratory system and lungs, thereby causing inflammation of the respiratory passage. Basically, it becomes an irritation and does not necessarily mean an injury or permanent disease. Some of the factors that affect the toxicity of substances are the amount entering the body, length of time in the body, the rate of absorption into the bloodstream, the physical nature of the chemical or substance, and the chemical nature of the substance. The age and health of the individual exposed is also a consideration in the effect of the toxic chemical or substance. Generally, we measure toxicity by parts per million, parts per billion, parts per trillion, lethal doses, lethal concentration, threshold limit values, and IDLH, or immediately dangerous to life and health. To give you an example of parts per million would be equated to 1 penny out of $10,000. Parts per billion equates to 1 penny out of $10 million, and parts per trillion would equate to 1 penny out of $10 billion. It doesn't take much, depending upon the chemical or hazardous material. Threshold limit value is the upper limit of a toxin concentration to which an average healthy person may be repeatedly exposed to on an all-day, everyday basis without suffering adverse health effects. If it's a gas, the TLV is normally expressed as parts per million. There are other measurements for specific types of gases, fumes, or mist in the air we breathe. When we talk about TLV or threshold limit values, there are other categories associated with the word. TLV-TWA means threshold limit value time-weighted average. The time-weighted average concentration for a normal 8-hour workday and a 40-hour work week, to which all workers may be repeatedly exposed without adverse effect. These time-weighted averages are simply guides. TLV-STEL, short-term exposure limit. This refers to a 15-minute time-weighted average exposure that should not be exceeded at any time during the workday. TLVC, or threshold limit value ceiling, the concentration that should not be exceeded even instantaneously. Let's now look at some specific types of hazards to help us identify hazardous materials. Air contaminants come in many forms, such as gases, vapors, fumes, and particulates. Gases are generally used in a compressed form and can affect all routes of entry. Vapors are formed by evaporation of liquids or solids. The amount usually depends upon exposed surface area, temperature, and vapor pressure of the substance and can be deadly. Fumes are usually metallic and formed by welding, cutting, or brazing operations and can be extremely hazardous to inhale. Particulates are composed of solid or liquid particles that are suspended or dispersed in air, such as dust, mist, or smoke. They can be explosive and hazardous to breathe. Other hazards include acids and bases that are harmful to your health. Quite often, certain acids, when mixed with other bases or chemicals, have a violent reaction and can cause explosion. Some basic safety tips and general precautions for these types of materials include: if you're not familiar with the chemical, find out about it. Read the MSDS and warning labels on the container. Observe written warnings and don't eat, drink, or smoke around chemicals. Change your clothing because you don't want to take hazardous chemicals home with you on your clothing. Ensure your work area is well ventilated and wear appropriate protective clothing. Clean up small spills to prevent being mistaken for water. Store acids away from bases to prevent reactions and know what reactions can occur from other materials. Always add acid to water, never water to acid. Let's not forget about solvents. These are very common to most businesses, and just because they are widely used, they can be hazardous to your health. Solvents can enter your body through inhalation, ingestion, absorption, and even injection. Injection of hazardous materials is usually the result of a puncture wound. Compressed air can cause the chemical to be injected into your skin and can also be contained in the other debris in the wound. There are many other potential hazards, but it's important to remember that these materials have a variety of methods to enter your body and bloodstream. Don't take chances. Find out what chemical or hazardous material you're working with and take action to prevent overexposure. Okay, we've discussed quite a few things, including toxicity, some of the effects toxic materials can have on your body, the basic routes of entry into your body, and some of the ways we measure toxicity, such as threshold limit values. What about hazardous materials? How do you identify them? Obviously, you look at the chemical name and follow the information printed on the label. That's one method. Placards and panels with an ID number are also methods of identifying hazardous materials. Placards come with many different means of identification. Some will say flammable, meaning the material inside is flammable, such as gasoline or acetone. Placards generally explain what the hazard is rather than the specific name of the material. Placards may be identified as being combustible material, harmful, corrosive, poison, explosive, and other similar identification. Often you will see an identification number of the material, and you can look up the specific hazardous material in your emergency response guidebook. The identification number 1005 means the material is ammonia. In the book, you'll also see guide number 15 for ammonia. Turn to the guide in your book, and it will provide the information for the potential hazards of the material and recommended emergency action. Your emergency response guidebook will pay big dividends when working with spills, leaks, or other hazardous waste operations. If you know and understand the hazards of each chemical with which you work, the more protection you have from potential exposures. Learning how chemicals are labeled and what information is contained on the label helps you understand the hazards and how to protect yourself from these hazards. Reading and following the information contained in the material safety data sheets is important in understanding how the chemical or hazardous material can affect your health and what to do when using, handling, storing, or disposing of that particular material. Knowing the information contained in the NFPA and HIMS labeling system are important, as they give you immediate information about the material. Most of all, do not attempt to take any action beyond your level of training. Know and respect what you are capable of doing safely. Be part of the solution, not the problem. Let's review some on-scene safety procedures for emergencies. Approach cautiously. Resist the urge to rush in. You cannot help others until you know what you're facing. Identify the hazards. Records, container labels, shipping papers, and/or knowledgeable persons on the scene are valuable information sources. Evaluate all of them, and then consult the recommended guide page before you place yourself or others at risk. New information provided by a shipper on the shipping document or obtained from another authoritative source may change some of the emphasis or details of the guidebook. Remember that the guide provides only the most important information for your initial response in relation to a family or class of hazardous materials. As more material-specific information becomes available, your response should become more appropriate for the situation. Secure the scene. Without entering the immediate hazard area, do what you can to isolate the area and assure the safety of people and the environment. Move and keep people away from the scene and the perimeter. Allow room enough to move and remove your own equipment. Obtain help. Advise your headquarters to notify responsible agencies and call for assistance from qualified personnel. Decide on site entry. Any efforts you make to rescue persons, protect property or the environment must be weighed against the possibility that you could become part of the problem. Enter the area only when wearing appropriate protective gear. Above all, do not walk into or touch spilled material. Avoid inhalation of fumes, smoke, and vapors, even if no hazardous materials are known to be involved. Do not assume that gases or vapors are harmless because of lack of a smell, as odorless gases or vapors may be harmful or deadly. In your emergency response guidebook, there's a page entitled Who to Call for Assistance. In the event you need more assistance identifying the chemical or hazardous material, you can call the Chemical Transportation Emergency Center, or ChemTREC, at 1-800-424-9300. This number is available 24 hours a day, but don't use this number unless it's an emergency. Certainly, this is not all the information that should be learned about the identification of hazardous materials. We haven't even touched on flammable or combustible materials, but it gives you an idea of what to look for and do in case of an emergency and when working with hazardous materials. The human body is a marvelous object, but it can be harmed in many different ways. It's up to you to learn potential hazards and to then use your good judgment, knowledge, and information to make the best choice for protecting yourself, property, and the environment.